Hi. Today we'll be talking about the concepts of discrete and continuous data, functions, whatever. Now the reason why I'm broad with that is that these two words have enormous meaning in mathematics, and many times when we hear them for the first time, they're difficult to understand. And so we kind of gloss over them. And as a result, we don't fully understand and appreciate what these words mean. So, the first introduction you might see to these two words is in reference to functions, right? If I was given a discrete function, I wouldn't be able to draw it by, doing a line and without lifting up my pencil. Right? I had a whole bunch of dots. You might call it a scatter plot. I can't draw this function, without lifting up my pencil. And so that's how I know it's discrete. But that's not really a definition. That's just defining, how I can tell it's a discrete function. What does that actually mean? Well, it means instead of being a smooth curve, it's a collection of points that aren't always connected. Whereas a continuous function, I would be able to draw without lifting my pencil up. It'd be a nice, smooth curve. And it can do, anything. And it can have any movement along this line, but it's always connected. If I were to zoom in to an infinitely small dimension, those points would still be connected to form this curve, this line, this whatever. And that's how I know it's continuous. And so that's functions. But even that doesn't fully grasp the difference between discrete and continuous. And as we'll talk about, these terms have direct application on our daily life. And you might say, okay, well, they're functions. I don't have a lot of relevance with functions. Well, think about this. We deal with discrete and continuous data all the time. So, for example, you're in school, and you walk into class and you notice, hey, there are like 30 people in this class. Well, you just recorded discrete data. The number of students in the class is an example of discrete data, which refers to data that has constraints. It can only take certain values. It can't take all the values, right? You can't have 1.5 students or 2.798 students. You can have 1 student, 2 students, 3 students, 4 students, 5 students. You can't have every student in between, right? And this is also common in technology. Your phone or your computer can't display every single image, every single speck of light that you would see outside, but it's able to approximate it by splitting it up into pixels and feeding it to you at a very fast rate. So discrete data can be pretty close to continuous, but it will always have limits. It can only take certain values. It can't generate that infinitely dense, smooth curve that we'd see with continuous data. And what is continuous data like? Well, continuous data would be a person's height, right? Within the range of human heights. You don't have a fixed height. You can be anything between 5'7" and 5'8". You don't have to be, oh, well, I'm 5'7" exactly, or I'm 5'8" exactly. You can be 5'7" and like 7.0000058, some crazy number, if you want to get it precisely. Or time, right? You can split time infinitely small, and you'll still have some amount of time. That's how it's continuous. And so if you're wondering about discrete and continuous, here's a good summary. Discrete data is counted, right? We look at it and we count it because there are certain limits to what we can count. The rolling of dice, the number of students in the class. Continuous data is measured. Someone's height, time, your weight, the length of a leaf, lots more. And these concepts are core of mathematics, and they proceed all the way up to the highest levels. The reason why we have calculus is we originally had, what we refer to calculus now includes both discrete calculus, focusing on discrete data, and infinitesimal calculus, which focuses on continuous data. And the merger of those two fields has created this enormously complex, enormously advanced mathematics today that we call calculus. So as you can see, it's important to know these concepts because they will pervade all the way up to the highest levels. And they make up a lot of our life. We experience time every day. You probably use your phone, which uses discrete data every single day. And that's discrete and continuous information. This is what these concepts mean in mathematics. That's it. I hope you found this helpful, and I hope you have a great day.